Eric Burgess here, and we've been asked to find the derivative of e to the 7x minus e to the 3x all over e to the 5x. So to do this, we could convert this to a product rule, which actually would probably be a bit easier, or we could use the quotient rule. So I'm going to go ahead and do it both ways. First, let's start with the product rule just because it seems like it'll be easier. So if we multiply both by e to the negative 5x, e to the negative 5x times this whole top piece. These bottom parts will simplify to 1, right? Because we'll get e to the 0, which is just 1. And we'll be left with y to the x equal to e. And then when we multiply in, the exponents add. So we're going to get 2x here minus e to the negative 2x here. And now we've gotten rid of any necessary use of the quotient rule or product rule because we're able to just combine these. And we're going to get, if we take a derivative, that y prime is equal to 2 e to the 2x plus 2 e to the 2x, negative 2x, right? Because when we drop down the negative 2, it's going to cancel out that negative and make it positive. And so this would be our answer. So there's sort of the easy way to do it. And that's the way I think is going to be the way, if you see this on a test, that's the way I would do it. But you can also confirm your answer using the quotient rule. So remember the quotient rule, I think of it as high d low minus low d high, ho ho. So what that means is the derivative of the high d low. So we're saying that y prime is equal to, so that's the derivative of this top piece, which would be 7 e to the 7x minus 3 e to the 3x. That's high d, and now we just write the low, so we're multiplying by the low, e to the 5x. And then we have minus low d high. So the low is e to the 5x, so its derivative will be 5e to the 5x. And then we just write the high, e to the 7x minus e to the 3x, like so. And then we can go ahead and put this whole thing over, and then it's ho-ho, or low-low, which would be just the bottom squared. And I'm actually going to write it out separately. You'll see why in just a sec. E to the 5x, e to the 5x. The reason I did this is because we can immediately take away an e to the 5x from everything, so we can simplify that out. If you want to write it more formally, you could factor it out first and then simplify. But if all the terms share it, you'll be able to factor it out. So I kind of just cross them out. So we're going to be left with y prime equal to 7 e to the 7x minus 3 e to the 3x minus 5 e to the 7x plus 5 e to the 3x, distributing that negative 5 in, over e to the 5x, e to the 5x. So we can combine like terms, and we're going to get 5, the 7x's can go together, so 7 minus 5, that's 2 e to the 7x. And the 3x's can go together, so that's also going to give us 2 e to the 3x. And this is all over e to the 5x. And you could stop here, but if we want to get to a similar form that we got to before, all we have to do is multiply by e to the negative 5x again. So you see this move still comes up later if you want to get to the same form. And we get y prime is equal to, and remember exponents add, so 7 minus 5 is 2. So we're going to get 2 e to the 2x plus 2, and then 3 minus 5 is negative 2. So we're going to get e to the negative 2x. So we get the exact same thing. And on a test, you could use this as a moment to write as expected. There's 2 ways to do it. And we get the exact same thing, which is a really nice confirmation. You can move on with a great degree of confidence. If you have any questions about this, feel free to drop them down in the comments below. Subscribe and hit that bell icon for future videos. And we'll catch you in the next problem.